right? So we have here algebra. So what is algebra? Algebra is basically using letters, right, or symbols, right, something to represent an unknown number or unknown quantity, right? So in primary school, we are accustomed to doing with known quantities, right? True, right? Good. But now, if you don't know a number, it's okay. We just use a letter to represent that unknown number or that unknown quantity, right? Nice. Algebra also uses the laws of directed numbers, right? This is very important here. Algebra uses the laws of directed numbers to what? To solve equations. Solving equations is one of the biggest things in secondary school mathematics, CSEC mathematics, right? We need to know to solve equations and simplify expressions. Simplify expressions, right? Good. So all this has come from algebra. But the key to doing solving equations and simplifying expressions is what? And even much more is knowing the laws of directed numbers, right? Knowing the laws of directed numbers. And directed numbers, there are two set of laws, right? There's the addition and subtraction laws, and there's also the multiplication and division laws, right? So I class them because they go hand in hand. The addition and subtraction laws go hand in hand. The multiplication and the division laws go hand in hand, right? So today's class, the session is only an hour. Normally my sessions is be a little longer than an hour and a half, 2 hours, right? But we have limited time, so we will be focusing on the addition and subtraction laws today, right? Not only the addition and subtraction laws, but how to apply it to simplify expressions as well as to apply it to solve equations. So this is what we're going to focus on today, right? But before we go on to the laws of directed numbers, let me just refamiliarize yourself with some things you're supposed to already know in algebra, right? So in algebra, these unknown letters and them, what we call them a variable, right? Or unknown, right? And when we multiply in a number and a variable or a number and a letter together, right? We just bring them together and write them as this. So 3 multiplied by x, for example, is 3x, right? 3 multiplied by x is 3x, right? 2 multiplied by x is what? 2x, right? 2 multiplied by x is 2x. Look over here. 2 multiplied by a is 2a. 3 multiplied by a is 3a, right? 2 multiplied by b is what? 2b, right? 2 multiplied by b is 2b, right? And when we multiply a number and a letter together, this is called our algebraic term. This is a term here, right? This is a term. And in this term now, we can probably label the parts of this term, right? So we just label this as a refresh. So anytime a number is multiplied by a letter, the number is called a coefficient, right? And the letter is called a variable, right? So I want you all to know this, right? What is a coefficient? What is a variable? When a number is multiplied by a letter, the number is called the coefficient, the letter is called the variable, right? Nice. So in this case here, 2 is the coefficient. What is the coefficient of this term? 2. 2 is the coefficient here, 3 is the coefficient here, and so forth and so on, right? Nice. Now, what you multiplying other terms now like this, watch. You multiplying two terms together. X multiplied by x. You're familiar with square numbers. So if somebody say, what is 2 squared? 2 squared is 2 multiplied by itself. 2 multiplied by 2. So x multiplied by x similarly is x squared or x to the power 2, right? So we see the difference here. X multiplied by x is x to the power 2 or x squared, and 2 multiplied by x is 2x, right? So you need to know the difference between those two, right? Nice. When you make sure and write down your notes, right? Could be after class, could be during class if I give a little chance, but mainly listen to the explanations, don't hurry to write, because everything will be sent to you, all right? Nice. Look again, I have it here again. X multiplied by x. So look here, what we're going to do here. We're going to fit in an x here, right? So let's say x multiplied by x multiplied by x. This is what? It's going to give you x to the power 3 or x cubed, right? X to the power 3, x cubed, right? X multiplied by y, students. X multiplied by y is xy, right? This is a variable term. Two variables coming together. When you multiply them, you bring them together, right? Same thing here. Y multiplied by x, right? You can also say this is xy or even yx, right? It doesn't matter the order. the order. When you're multiplying letters, it don't matter the order. Once you have a number, the number must come first, of course, right? I'm going to tell you why we do the order don't really matter when you have two letters, right? 2 by 3 is 6, and 3 by 2 is also 6, right? So it don't matter which one, which order, right? But I prefer it in alphabetical order. So if I have y by x, I'll put xy, right? Yeah. Alphabetical order, right? Nice. If you have an next one here to do, a multiplied by a multiplied by a. This is a to the power 3 or a cubed, right? Nice. Look this one here now. We have two terms to multiply here. Multiply numbers. So 5, 3 is 15. X multiplied by y is xy. Simple, right? If you have an next one here, 2x multiplied by 5x. 5 2s are 10. X multiplied by x is x squared or x to the power 2, right? Next. All this you're supposed to know is just a little revision, but 1 or 2 persons probably didn't understand it in Form 1, right? If already missed classes, or if I didn't get a chance to do it due to online learning and many other limitations in school. So that's why I say, okay, we do another revision and everything. So in case you miss it, you miss it. You know, get it back, right? If you already know this, I'll revision, right? Nice. When we add in terms, students, we do just bring them together like when we multiply in terms, right? So when you add in x and y, we can bring it together and say xy. This is wrong, right? That is totally wrong. X plus y is x plus y, right? That is what it is. When you multiply x and y, yeah, you bring them together and say xy, right? No problem. 2 multiplied by b is 2b. 2 plus b is just 2 plus b. Can bring them together, right? Nice. And also to get 2b, you can say, okay, b multiplied by 2 is not b2. b multiplied by 2 is also 2b, right? Good. Nice. So what we do when I didn't letter come first, we still write it as this 2b. We still write the number in front, the coefficient in front, and the variable after, right? Next. So again, we're going to look at the laws of directed numbers. This is a real reflection algebra, but the laws of directed numbers is what going to take it through everything in algebra, right? Laws of directed numbers, everything in algebra, Form 2 level, right? There are other things to learn in algebra, but you can't understand that unless you know the laws of directed numbers, right? So it's like a foundation here. You master the laws of directed numbers, then you're going to master next skill. Then you're going to master next skill. You put these skills together and you do a big topic now, right? Probably in Form 4 or something, when you do bigger topics, right? Putting all these small skills together, right? Directed numbers is one of the key skills here in algebra, right? Next. Going on here now, right? So we're going to do a little recap of the addition and subtraction laws of directed numbers, right? So the first law is the same signs law, right? The same signs law. How I just remember the same signs law, right? When you have same signs, what we just do, we're going to add and keep the same sign, right? We're going to add and keep the same sign, right? I do another example here, right? For example, let's just say, okay, we have -3, -7, -5. All these numbers here carrying the same signs, and we know we need to do an addition or subtraction, but we call the addition and subtraction laws just to refer to it, right? But because it's the same signs, not because it have a takeaway, we're going to take away. No, we're looking for the signs on them, right? So same signs, we're going to add and keep the same sign. So what's here? All have these negative signs here. So we're going to say 7 and 3 is 10 and 5 is 15. So this is -15. We added the numbers together and we keep the sign, right? So this is for same signs. Anytime you have same signs, this is what we're going to do, right? -10, -20. Again, same signs, add and keep the same sign. This is -50, right? Nice. We can even go further to say, okay, we call leveraging some algebra terms here, right? So let's say -8x -2x. If you add an x term, students, guess what? Is that x term going to be the result, right? And again, same signs, and keep the same sign. This is -10x, right? Simple, right? Nice. Even addition sign too. Let's say you have 2x squared add 5x squared. We know it have no positive sign here, but it is understood. Once a term is a first term, right? And it don't have a sign, it's understood to be positive. So you can put it in as positive here. So you know this is positive 7x squared, but we know the positive is understood, right? Next. So this is the same signs law, right? So I want you all to understand the same signs law. You can put it on a cue card. A cue card, if you don't know it as yet, put it down and revise it, or even why get have an cue card too, right? Especially in Form 2. You always have it on your desk ID or in your pencil case. So you can always look back at the laws done when you're doing the next topic and you're looking back to see which law it is, you know, to refresh yourself, right? Nice. Different signs law now, students. Different signs law, obviously, you're not going to have same signs, right? different signs law, we're going to what? We're going to subtract. Subtract and keep the bigger sign. Right? And this one is fairly simple as well. We'll look at the example here. Watch. 12 take away 4. The 12 understood to be positive. We know that, right? If you know the 14, keep the 14. Right. This is like normal subtraction, but you keep the sign of the bigger number. Right? 12 take away 4 is 8. So the answer here is positive 8. So let's put in the 8 here. You don't need to put the positive here. I just put 18 to show that, okay, we're using the rule, right? Keep any sign of the bigger number, right? Example again here now. Minus 7 plus 10. We have different signs? Yes. Right? Different signs here. Because the 7 carrying a negative, the 10 carrying a positive. You're going to subtract and keep the sign of the bigger number. So this is positive 3. So 10 take away 7 is 3. We keep the sign of the bigger number, right? Nice. Example again here. Let's say, okay, what? 2 take away 9. 2 take away 9. The 2 don't have no sign. But guess what? We know once a term is a first term and it's not carrying a sign, the sign is understood to be positive. The sign is understood to be positive. So you're going to say, okay, what? Different signs, subtract, and keep the bigger sign. So the bigger sign here is in 9, which is in negative, right? So this is going to be negative 7, right? Negative 7, right? Nice. Next example. Let's just say, okay, we have minus 15 plus 3, right? Different signs again here, students. We need to subtract and keep the sign of the bigger number, right? 15 take away 3 is what? 12. And we keep any sign with the negative in it, right? Nice. So this one is the bigger one, right? Right? Take note, if it was minus 15 minus 3, this is not different signs. This is what? Same signs. So we're going to use the same signs law, right? So I'll put this example up here, right? This example here fall under the same signs law, right? So minus 15 minus 3 going to give you minus 18, right? So you see, same signs, you need to recognize the sign, identify that quickly, and then you can tell you which law to use. And the laws are not hard to learn, the laws are easy to learn, very easy to learn, right? Nice. And we are accustomed to those laws. Even in primary school, we was doing this, but we didn't really wasn't really familiar with the negatives too much. But now we know that even my first number could be negative, right? My first number could be negative. So if you bring in some algebra here, right? Minus 20x plus, let's say 15x, right? What? Different sign, subtract, keep the bigger sign. This is minus 5x, right? Yeah. You keep any sign with this one, right? The larger number, right? And this is an x term we subtracted in terms of, so you keep an x term here, right? Nice. So this is one application. This is called simplifying. Simplifying, right? So the application here at the form 2 level, right? We limit it to what? Solving and simplifying. Solving and simplifying, right? Solving equations. Then we're going to go on to something called inequalities, right? Inequalities are a little more challenging to work with, but once you understand how to solve equations, inequalities straightforward as well, right? They just have 1 or 2 extra laws to learn, right? Nice. Good. So that's simplifying, we call this, right? Nice. Keep in mind as well, we are touching the multiplication and division laws, right? Next class, we would like to do this. We like to touch on the multiplication and division laws, right? So you can run again here. Right. So in mathematics, we have something called like terms. Like terms is a concept in algebra as well. And like terms are terms of the same variable, right? Meaning they have the same unknown term attached to it, right? Good. So like terms, right? When we say like terms have the same variable, right? So all these here in the first one here, all these are like terms because they have the x squared attached to it, right? Good. These are like terms. Look at the second one. We have xy here, we have a xy here, we have a xy here. We have like terms again here, students. Like terms again, right? Nice. Next one here, we have what? AB. All of them carrying the AB. So we say, all right, this is a AB, 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 AB. All of them are like terms, right? Unlike terms, however, have different variables, right? Different variables, right? And why does we need to know like terms and unlike terms for? Because there's a specific rule we need to know, right? This rule is what? We can simplify like terms, because simplify like terms meaning like how you are simplifying these numbers here, these terms here, x with x, we can simplify them into one term, right? That's what simplifying is about. Bringing a good few terms into one term. right? So making it simpler, right? Simplifying, making it simpler. We can simplify like terms. So only if terms are like, meaning they carry the same letter, the same variable, right? Throughout, we can simplify them using the laws of directed numbers. Right? So you can simplify like terms, students, using the laws of directed numbers. And what are these laws of directed numbers? So far we know what? Same signs, add and keep the same sign, and different signs, subtract and keep the bigger sign. The sign of the bigger number, right? Nice. Now, look at it now. Unlike terms now, guess what? We can't do nothing with unlike terms. So, the note here is simple. We cannot simplify unlike terms. Therefore, we leave them as is. Right? So if somebody tell you now, go ahead and add and subtract this here. Nothing here is matching to add to each other because this first one is a x squared, right? This one is a x, this one is a xy, and this one is a number, a constant, right? Yeah. If you tell me now simplify this here, yes, you can simplify this here. Bring all this into one term, yes, you can simplify that, right? Using the laws of directed numbers, adding and subtracting, of course, right? This one, you can't do nothing here, you leave it as it is, right? Nice. So these what like terms are, right? And like terms is a topic by itself, right? And like terms is important for simplifying algebraic expressions. Simplifying algebraic expressions, right? Next. So before what we want to do here, students, we want to go on to do some examples here and see how it is using laws of directed numbers to do some simplification, right? But look at this here now. Before we go into that, right? I just want to recall the parts of an algebraic expression, right? Although we're familiar with them, we're going to recall them, right? Good. So we have here, students, what? 3x. 3x. This is a algebraic term here. The whole thing is called an expression, right? This is a term. This is a term. This is a term. We have how much terms here? See how much terms you have here? We have 1, 2, 3, 4, 5 separate terms. Each term has their own sign, right? 3 here on this to be positive, right? Nice. Good. So there are 1, 2, 3, 4, 5 terms here. 5 different terms here. Any like terms? No, nothing like. This is a x, this is a y, this is a constant, this is a a squared, this is a b term, right? 5 different terms here. And from these 5 terms here, students, what? We could label them or name them or make them into what? Into coefficients, class them as variables, whatever the case may be, right? So look at here. This here, students, is what? 3x. This was derived by taking 3 and multiplying by x. So this here is called a coefficient, right? X is called a variable, right? Obviously, you know, the 2 here, positive 2 is a coefficient, yes. So this is a coefficient again, right? 2 is also a coefficient. And y is the variable, right? 4 now. 4 is not a coefficient. Y is not a coefficient because it don't have no variable attached to it. So we call this a constant. A constant. We call this a constant, meaning it is a fixed number, right? Constant means it don't change. It's a fixed number right here, right? Nice. 3 is also a kind of considered a constant. 2 is considered a constant, but because it is being multiplied by a variable here, 3x, it's called a special constant, which is called a coefficient. Coefficient, right? Nice. I go on here now, watch. I see in minus a squared here, students, minus a squared, right? And when you have a minus a squared like this now, this is a variable term. The a squared is a variable term for sure, right? But what is the coefficient here? Every variable has a coefficient. When it doesn't have one, it is understood to be 1. So you could put any 1 here. Feel free to put any 1 here, right? Although it's not there, put it in, right? So now we can say, okay, minus 1 is the coefficient and a squared is the variable. Same thing here, plus b, right? B don't have no number in front of it, it's understood to be 1, right? So we say, okay, b is what? B is the coefficient, and, no, sorry, 1 is the coefficient, and b is the variable, right? Right. So this is what makes up an algebraic expression. Coefficients, variable, constants, and we only have one constant here, right? But constants are part of our expression as well. right? What again makes up this here, right? Constants, coefficient, what again we could say here? Let's say what? Um, Constants, coefficient, operations. So when I say operations here, what I mean by operations, there are what? Four operations in mathematics, but you see the addition here is operation, multiplication is understood here, right? We have some subtraction, right? Plenty addition, subtraction, and multiplication, right? So these are the parts of an algebraic expression, right? For example, if you have something like this one, 2xy plus 1, xy is the variable term, this is a variable term. This is the coefficient, and 1 is the constant, right? And addition sign, this is just an operation, right? Right, this is just an operation, right? Next, let's go back, right? So we see here, we recap a lot of things in algebra. You're supposed to know this already, right? Make sure I know this, right? The laws of directed numbers, important laws, right? Some persons just say, okay, a negative and a negative is a positive. No, you have no such law like that, right? Negative and a negative, no. Same signs, add and keep the same sign, right? Different signs, subtract and keep the bigger sign, right? We win again here. Like terms, you know what are like terms now? And to simplify like terms, and we know the parts of an algebraic expression, right? Yeah, good. Now we're going on here now. We can simplify like terms using the laws of directed numbers. We talked about that already, right? So what I want to do here, I want to go on to simplify these here. We're going to simplify these here, right? So in order to simplify this here, what we need to know here is what? We need to go ahead and we have to go ahead and identify if they are like terms and then go ahead and simplify, right? But before we do that, I want to give you all a few minutes just to take down the laws of directed numbers. So you can take down things on this page here, right? Take a few minutes, take this down. If you want, you can leave out a page for this here, right? When I have the notes, send the notes to you all, but take this down so you can always refer back to these here. I want this down in your books, right? So I'll give you all a few minutes to take this down. Go ahead and do that, right? Right. You all can always raise your hands or comment and when you all finish writing this, right? So everything we will be doing in today's class, basically, we using what we know in algebra so far, right? And mainly these here, the laws of directed numbers, right? Supposed to know this already from form 1, but it here already, write it down, right? A little revision, and we're going to use this to solve and simplify as well, right? Right. So there we go into here now, right? Right. So we're going to do simplification here, right? We're going to do these three here as a class, and then I'm going to give all this on the practice here, right? Treat the practice, right? So there you go ahead now. So we have here what? 2x plus 7x, right? I see this is like terms here. Nice. X with x, good. Same signs, add and keep the same sign, right? So this is what? Plus 9x, right? What again? We see an a with a here. Minus 3a minus 5a. This is like terms, right? We see the a's there. And which law we're going to use here? We're going to say, okay, same signs again. Same signs again. We're going to add and keep the same sign. So 5 at 3 is 8, so this is negative 8a, right? Good. Because why we say negative 8a again? Because we have same signs. Same signs, add and keep the same sign, right? So let's go back to that same signs law here. Watch. What do you same signs law here? Same signs law, add and keep the same sign, right? So we're going on here now, right? Last one here again. We have two constants here. This is like terms, yes. We can simplify a number with a number, right? We're going to simplify this using the same signs law again, which is add and keep the same sign. So minus 6 minus 8 minus 6 is minus 14, right? And nice simple. That's the answer there. You can't go further than this because everything is unlike. This is a x term, this is a term, this is a constant. So we have to do, when you're writing it, write it so far apart, right? If you write the answer like this. Plus 9x minus 8a minus 14. And that is it. That is it, right? Yeah, that is it. We could do that here. Next one here now, watch. We have here xy here and xy here, right? So when you have xy's coming together, students, what we say? These are like terms. And we can simplify this using the laws of directed numbers, right? So I want you all to look at this now. Which law are we going to use here? Somebody could comment in chat, right? You all could comment in chat. Which law are we going to use here? We're going to use the same signs law, we're going to use the different signs law. Look at it here. Anybody want to say it? Same signs law, different signs law. Right, I've seen chats, people commenting in chats. Good, different signs law. Excellent, right? Different signs law. One person said same signs. Now we can't use the same signs law here, right? Why? Because the 11 carrying a negative and the 10 carrying a positive. So if you look back, watch. If you look back, we say what? We're using the different signs law here, which is to subtract and keep the bigger sign, right? Yeah. So we could simplify the xy's. You're going to get xy, right? And you're going to get what? Minus 1xy, well, that's minus xy, right? We leave it as minus 1xy, minus 1xy, right? So we subtract and keep the sign of the bigger number. Next one, I see different signs again here, and I see a squared with a squared. A squared could simplify the a squared, right? So we're going to simplify this using the different signs law again. Subtract, keep the bigger sign, 10 take away 8 is 2, so this is negative 2a squared, right? Last one here, AB with AB, yes, we could simplify. And this minus AB, yes, students, right? There's a 1 understood here, so you could put in the 1 here, right? You could put in the 1 here. The variable term, it doesn't have a coefficient, so it's understood to be 1, right? So you're going to say different signs here, what? Subtract and keep the sign of the bigger number, right? So you're going to get the answer in terms of AB, yes. So 6 take away 1, 6 take away 1 is 5. So this is plus 5. We keep the sign of the bigger number, right? Nice. And this is how we simplify, students. This is how we simplify. You look for like terms, x with x, a with a, number with number, a squared with a squared, ab with ab, xy with xy, simplify them, and it's just to decide which law to use. And only have two laws we can use. Two laws we can use, easy. Either the same signs or the different signs one, right? Nice. We're going on again here now to the last question here, the last example. Right, pay attention to this one. Right. So let's look here now. I see this is 2x squared here. So this is positive 2x squared here, right? Now, I see y and x stayed here. We can't simplify x squared with a y. So guess what? We're going to find x squared to simplify this with. So I see 9x squared over here. So we have to do any question here, students have to rearrange to see if you want, right? You can rearrange it, right? When you working column, rearrange it, right? And you could say what? This is what? Plus 2x squared minus 9x squared. And now we can simplify this and say what? Different signs, subtract and keep the bigger sign. So 9 take away 2. 9 take away 2 is what? 7. So the answer here is 7x squared minus 7x squared, right? Minus 7x squared, right? We have here minus 7x squared. Now we're going to look for more like terms. I've seen y's over here. We have y's over here, right? So we say what? Same signs now. Why same signs? Because a negative here, negative here. Same signs is what again? Let me go back. We have same signs. We're going to add the numbers and keep the same sign, right? Okay, add them and keep the same sign. So this is what? Minus 8y. Minus 8y, right? Next. I'll use the next color here now. We're going to go on to what? To the constants here now. The constants. So we have the numbers here, right? Two numbers could simplify, yes. What law are we using here? We have somebody here now who wants to answer this. So they could unmute, right? Raise your hands, unmute you all, and you can answer this here quickly. Anybody? Anybody want to answer? No? Kyla, which law are we using here?
Different signs losses.
Different signs law, correct. Which is what? Different signs law is what?
Sign.
Subtract and keep the bigger sign, right? Subtract and keep the bigger sign. So we subtract this, what? 15 take away 6 is 9, so this is negative 9. Negative 9, right? Nice. The last one here, could we simplify this? Yes, because I've seen a B term here and a B term here, right? Simplify the two B terms, right? Same signs, add and keep the same sign again, right? Add and keep the same sign. So we have the same signs here, different signs here, different signs here. Now this is same sign. And keep the same sign. So this is minus 8B, minus 8B, right? So I want you all to take this down. I'll wait for you, right? Right. So this is how we just do this. Make sure write down what is in the notes, right? There are 5 pages I worked so far, right? So we have the questions to try here now, right? So if you go ahead and try this, right? Try these, right? Look for the like terms, simplify them using the laws of direct numbers, either the same signs law or the different signs law, right? And when you simplify them, write the answer, we're going to correct this, and then we're going to look at what? We're going to look, well, we're going to look at solving, all right? Let's look at solving.
Yes, sir. So you can hear me?
Yeah, hey, yeah. Go ahead.
Alright, so for 3x, but take away negative x, 9x, I got 6, negative 6x.
Right, excellent. We say different sign, subtracting the bigger sign. Go ahead.
And the second one, I got 11, negative 11y.
Right, so we say negative 5y. Right?
Yes, sir.
Nice. Because you subtract again, different signs again. Good. Last one.
And for the last one, I got negative 7e.
Negative 7a. How you got negative 7?
Oh, sorry.
That's okay, that's okay. You see in same sign
11,
here, right?
sir. Yeah, 11, sorry.
Nice, negative 11 here, right? So good. It's okay to make mistakes, right? Make a mistake, I know that small thing. You correct it, so you won't make it again, right? Nice. So here was same sign,
Yes.
and actually same sign. So that was excellent work, right? Excellent work. Anybody
Yes.
else want to help with the next one? Somebody else? All right, well, I will do the rest, right? So we want to do equations today as well, right? A little bit of equation. So let me work on the rest here. Let me see. I see hands coming up as well. Somebody hand raise up just now. No? All right. So let me go in here to the next one, right? So look here. One time I see in this here, AB, for anyone here, this is what? This is, how you call this? Like terms, because we have AB and AB. And we have same signs, and keep the same sign. Remember, this is our one here, right? So this is minus 6AB quickly. Next one, different signs, x squared with x squared. Subtract, keep the bigger sign. 8, 9, 10, 11. So that's minus 8 x squared, right? I mean minus 11 bigger than each, right? So you take away. Last one here, same signs again, and I keep the same sign as minus 10. Simple. And you're done, right? Nice. Look at the last question here now. Right? The last question, right? All of them is xy, right? So what I prefer to do here, do them in twos, right? Do the first two here, and then do this two here. And I mean, you can simplify again because all is in xy. So you can bring all the xy's into one xy term, right? Nice. So you simplify the first two here. We're going to use same signs, of course. Same signs, and I keep the same sign. This is minus 4 xy because what? 3 and 1 is 4, and I keep the negative sign. Good. 10 and 6 is 16. This is the same signs again, right? Plus 16 xy. Now what? Now we have xy and xy again. So you could go again, right? And to go again, we need to use the different signs law, which is subtract and keep the sign of the bigger number. 16 take away 4 is 12. So the answer here is 12xy, right? And this is the final answer, 12xy, right? Correct, correct, correct. By the show of hands, all who got all correct. Right, excellent work, Kyla, right? Good, I see Shivani, good. A good bit of hands went up, right? Excellent work, right? So that means you all understand this. Make sure, take them all the other notes for homework, right? And we want to go into solving quickly, right? So let me talk about solving now, right? So before we was dealing with expressions. Expressions meaning we could only simplify them, right? Equations now, students, we could do with equations, we could solve them, right? We could solve equations, right? So we're gonna take down solving equations. Right? But when we solve an equations, how we just solve equations? We need a little note here, right? And I'm going to go in detail because most of you do this in Form 1 already, right? So I'm just going to do a little general note here, right? When solving equations, right? When solving equations, we perform the inverse operation, on the other side of the equation. Right? Nice. So because we only do the addition and subtraction laws, we're only going to look at solving equations with addition and subtraction, right? Well, next day when we do the multiplication laws, we're going to go further on into this, right? So let's look at the two operations we know so far. We know addition is an operation, right? And the inverse of addition The inverse of addition is what? Subtraction, right? And what again? We know subtraction is operation and inverse of subtraction is addition, right? So if you write add here, addition, right? Inverse of addition is subtract. The inverse of subtract is what? Add.
Yes, sir.
Nice. Good. Excuse your handwriting, right? So, right, so let's go on here. So look at some examples here, right? So I hope you all could follow along with these examples here, right? Watch. Example, we have here what? X add 8 equals to minus 2. X add 8 equals to minus 2. When this is solved by equation, you want to get x alone on the left hand side, right? We know that already, right? So what we just do here, students, we just want to do the inverse operation. Perform the inverse, keyword is inverse operation on the other side of the equation, right? Keywords here, right? Next. So look at what we're going to do here, right? X plus 8 equals minus 2. You see this plus 8 here? We want to do the inverse of adding 8. So the inverse of adding 8 is what? Somebody say it. Subtracting 8. So you're going to say what? Minus 2 subtract 8. And notice something. The minus 2 will not change in the right hand side. The right hand side will remain in whatever it is, it will remain in so, right? So x is equal to same signs here, add and keep the same sign. This is minus 10. And that's the answer for the equation here, done, right? Nice. I mean, today we're doing simple things, little revision, right? A few classes from today, we're going to do a lot more challenging equations, right? These are the basics here, right? So the basics, I want to make sure everybody understands the basics. Class right now, 1 or 2 persons who probably didn't understand this when they was in form 1, right? So let me revise everything from basics so everybody can pick up, right? Most people probably understand it well, so you all this is revision for you, right? So let's look at this one here, students. Now look at this one. X minus 7 equals minus 3. Now we have here minus 7. Look, I like to draw a circle and show the movement. I show that, okay, I'm moving this minus 7 on the other side of the equation. And when I move it, I'm doing the inverse operation, right? So the inverse of subtracting 7 is what? Somebody else now. Somebody else. Inverse of subtracting 7 is what? Adding 7. Excellent. Adding 7, right? And when we say adding 7 here, we need to identify which law to use. In the first case, we look back and they realize what? The thing I make it write down. Same science law here, right? The second case going to be different science law, right? So you need to be mindful of which law you're using to know, right? Be mindful. Although we know how to move the term across and okay, do the inverse operation, we need to know which law to use here now. This is the different science law. Subtract the bigger sign plus 4 is the answer, right? Nice. There's some more examples to look at here, right? So let's at next example here, right? So let's just say, okay, what? X plus 6 equals to what? Minus 15, right? X plus 6 equals to minus 16. So we could say here, move this on the other side, right? And do the inverse operation. See, it is okay to draw a circle and show you drawing your arrow to move it across because why? Helping you understand what you're doing, right? The 15 remaining the same, eh? Now minus 15, not changing at all. Is the 6 we're showing you 6 going to move and come here, right? Next day. And the inverse of addition, adding 6 is taken away 6. And here we see same signs again, add and keep the same signs. This is minus 21. Same signs, add and keep the same sign. Nothing wrong here, right? Been going good so far. Next example, what are we going to say here? Let's say x minus what? X minus 15 equals to x minus 15 equals to what? Let me say 2. X minus 15 equals to 2. Right? What? This minus 50 now. We're going to perform the inverse operation on the other side. So x is equals to 2. The 2 is understood to be positive, right? Are remaining the same, right? Good. And the minus 15 inverse of subtracted 15 is added 15. Right? So x is equal to 17. Because 17 take away 15 is 2. 17 take away 15 is 2. Right? You see that? 17 take away 15 is 2. Right? In this case, minus 21 plus 6 is minus 15. Right? Yeah. So understand what we're doing here, students. We're doing the inverse operation on the other side. So whenever we add, we're going to subtract on the other side. If we subtract, we're going to add on the other side, right? Yeah. And guess what? We are doing the multiplication and division laws yet. We'll leave it up for next day, right? Next day, we're going to do some simplification and multiplication laws and the division laws. And then we're going to look at how we can solve equations using that. And in following class, we're going to bring all together and solve complex equations, multi-step equations. We call these here one-step equations. Why? because it only involves one step, right? Then you have two-step equations, three-step equations, fractional equations, simultaneous equations, quadratic equations, right? All those things you have to learn in C-Sec mathematics, right? In Form 3, you can learn simultaneous equations, you got yourself quadratic equations, right? So there are many types of different equations, right? If you're going to do add maths, right? There are other types of equations as well, right? Or even Form 6 maths, if you want to go into engineering, differential equations, all them things is equations. And I say algebra is about 3/4 math, right? The C-Sec level, 3/4 math. So you need to know your algebra rules good. So make sure, what I want you all to do, make sure you have all your notes in your book, number one. Number two, read over your notes, go through all the examples, be familiar with it, take your pen, write back on we need to write them back. And also, you can look at the recording. I'll send you recording for you all in the chat. And well, again, I'm going to send some homework for you all to do, right? Not much homework, but take advantage of the holidays to improve on your maths. If you're getting 80s in maths, you're looking to get 95 and above, right? If you're getting 60s, you're looking to get in the 80s, right? If you're getting 50s, you're looking to get 75 and above, right? Looking to improve your score, right? Nice. So make sure and take this down. I'm waiting for you all.